So I played a little bit around and I found very good help at this website on their microcontrollers. There is a tutorial. This can also be translated with Google Translate, it's very good. I use this one and some examples of the datasheet to get somehow a little bit code on there. The first thing I want to show you is we are defining this constant FCPU with 7,372,800 Hz, which is 7.37 megahertz. When we tested at the ATMega8 the clock stuff, it was not accurate from this, and so, but on here we have this megahertz thing, the 7 mega, and we set it now correctly in the source code, so functions and delay functions will work better, and I want to show this. So we have on here currently set a delay of 150 microseconds, and this is what we see on here at the scope. We have here, let's make it time division 50 microseconds. So we have 3 boxes. So every time it waits 150 microseconds before it changes the state. I will change in the code to, let's say, 250 microseconds, okay? I will program this thing, it goes away and comes back. Now we have 5 boxes, 1, 2, 3, 4, 5. So these are, so we are sure that the frequency we are setting in the program is also driving the IC. So this is one thing. The other thing is that you see here that it's commented out. I will comment in a UART string function. I did with the help of this tutorial, and the ATMega is speaking, and we can maybe disable this stuff. We don't need this, and we can output this string. Let's start the program, and on here sits a terminal, and we see, here we go, ATMega is speaking. Now you see this. It is really fast. I figured out that we need to wait 1 millisecond approx in the function of UART put string. So if UART wait milliseconds bigger than 0, then delay, this is a bug. You shouldn't set this also to this value, right? So okay, so we are waiting a specific time. So let's compile it and program it and go on here again. On here. If we would say that it should wait 1 second, let's program. You see here, that's clear received. Here we go. You see that it's sending every second 18 mega. Okay, and if you are too fast, then the terminal program somehow is losing. Okay, so I go here again, 2 milliseconds, that doesn't matter. Compile program and move on here, and then we see again on there that it's working to send stuff out. And as last, we want to receive things. So we are here, and if I am entering the capital letter D, then the letter D is repeated backwards, send 1 character and weird stuff, I don't know. anyway send a big E. This is big E. So this is because so and now the problem, the bad thing is the following. If you look on here, we see that I use now the complete serial line, but I can't use the programmer if the receive line is pulled in. The programming would fail as they are interfering. You remember, we are sharing the pin 2 and pin 3 with ISP and serial, so I need to disconnect the center one, the RX thing. Now this phone is able to contact this IC and program it. So this is the price we have to pay. You see, fail to launch the program. And let's remove this one, and I'm playing around with this \n and a new line and line feed backwards return statement, and it somehow it's not interpreted from the terminal program. So, and we are also not in interrupt modus, we are polling using the function get character. So let's program this thing on here. You see on there, on here. Let's program it. Okay. So, and now again I need to plug in the RX line, and I need to remove the programming thing. Okay, and now if you disconnect, connect, clear received, clear transmitted, it is waiting for something. So let's make a capital D, and now this one has received. I don't know where it says this, the letter T. The T. Okay, on here. Okay, so Z. Okay, or small letters. Also, what about German umlaut is not this. Okay, so let's make a asterisk. Okay, so this terminal program is not interpreting. I don't know if there is a way to say you are ASCII terminal or whatever. I don't know. It doesn't matter. But we know that the microprocessor, the ATMega board, is able to transmit and receive. And now we are at a position where we can build upon this, because we have contact to it. We are able to write code for our application, for the keyboard encoding stuff, right? Okay.